Using class and objects, find the voltage required for given values of current and resistance. The formula is V equals I times R. So here comes the program code. And this is the class named voltage. At the end of this class declaration on line 14, we have declared the object named V1. What it does is, it will create the object V1 by allocating memory storage space for this object, and then will assign the reference of memory address location to V1. The object will be copied with everything as declared and defined in the class voltage. So we have two float variables, I and R, with individual memory spaces allocated. Then we have access specifier public. It means the declarations that come here onwards will be publicly accessible within and outside this object. It also means that I and R, which were declared before the public statement, will have restricted access as they will be private by default. Then we have the setValue function declaration. It is defined after the main function, from lines 25 to 29. It would carry two float variables as parameters, and would return no value. We also have the volt function. It would carry no variables as parameters, and would return one float value. Note that the volt function is defined within the class itself, here the object. Remember that every distinct object of a specific class will have separate copies for their data variables. But the objects will retain only one copy of the function. And so, all objects of the same class will share the same function. The program control after entering main function will allocate space for float variable named V. On next line, it calls setValue function of the object V1. Two values, 10 and 2.5, are passed into this function. So the setValue function of object V1 is invoked. It's defined here. The values passed into it are referred as A and B, respectively. This value in A is assigned to I. And then the value in B is assigned to R. In the program code, program control shifts to line 19. Here, the function named volt is called and the result it brings back will be stored in variable V. So the volt function works for object V1. What does it do? It returns the value of I, multiplied by the value of R. So 10 times 2.5 is returned to the main function where it was called. The result 25 is stored in variable V. On line 20 of the program code, we instruct to print the given value of current supplied. On output screen it's printed. On line 21 it's instructed to print the given value of applied resistance. It's printed on screen. On line 22, we have asked to print the value of voltage required. The value we computed and stored in V is printed on screen. And then we come to an end of this program. In this program, you learned how to apply class and objects for finding the solution to a given problem. You can modify this program to ask the values of current and resistance from a user at runtime, and then provide them with exact value for the voltage required. You can then reuse the class or its object in this or other programs.